Good afternoon, class. We are moving on to our very last section of circles, and this one is about segment relationships in circles. So 10.5 is about angle relationships. Now we're going to talk about segment relationships. So to start off, we have 4 vocabulary terms that we need to define. Our first one is segments of a chord, and that is when 2 chords intersect or cross in the interior and this is where each chord is divided into 2 sections. So that's segments of a chord. Our next definition is a tangent segment. Tangent segment is a segment that is tangent to a circle at an endpoint. So unlike a previous tangent line, that was a line that kind of grazed the side of a circle, this time we have a segment, so it has an endpoint on both ends. So a segment secant, or a secant segment, unlike a secant line, this one has 2 endpoints. So a secant segment contains a chord of a circle and has exactly 1 endpoint outside the circle. So that is a secant segment. Now we have an external segment. So an external segment, very similar to how it sounds, is an external segment. So it's a segment outside of the circle. And so this is the part of a secant segment that is outside the circle. Okay, so you'll see pictures of these 4 definitions onto our next page. Now we have theorems. We have theorem 10.18, segments of a chord's theorem. So if 2 chords intersect in the interior of a circle, then the product, remember product means to multiply, of the lengths of the segments of one chord is equal to the product of the segments of the other chord. So in this case, we have a circle and it has 2 chords. And both of these chords are fairly similar. So it says we multiplied EA and EB. So we have EA times EB. So if we multiply that, then it will equal the product of EC and ED. So if you were to multiply those 2 together, they have to equal each other. So in this example, we have find the value of x. So I have a circle where from M to N it is x plus 2, N to J is x plus 4, N to L is x plus 1, and K to N is x. And we want to find the value of x. So we have a chord that is Kn and J, and then we have our other chord, which is Mn and Nl. So if we were to multiply products of these 2 and we set them equal to my other chord, so I have Nk multiplied with Nj equals the product of NL and NM. So those are my two products that I'm multiplying together. So we know that NK is X, so X times NJ, which is X plus 4, is equal to NL, which is X plus 1, times NM, which is X plus 2. Now for this section, you will need to know how to FOIL, or box method, or area model. So you will need to know how to do that, as well as factor in order to get some of your answers. So for X, I'm going to distribute. So I have X squared plus 4X. And then this one, you may use area model or use FOIL or things of that nature. So if I wanted to use the area model, for example, or a box method, I have X and 1 and then X and 2. So I have X squared. In my next box, I have 2 times X, which is 2X. 1 times X is just X. And then 1 times 2 is 2. And so to elaborate on this, I have X squared plus 2X plus X plus 2. Now I can combine like terms on just one side. So now I can combine terms on just one side. So I have X squared plus 3X plus 2. And on my left-hand side, I have X squared plus 4X. Now I'm going to subtract what I don't need. So if I were to subtract X squared, I'm left with 0 on both sides. They cancel. So I have 4X equal to 3X plus 2. I'm going to subtract 3X from both sides. And 4X minus 3X is just X, which equals 2. And so, again, you will need to know how to FOIL, use area model, or box method in order to know how to expand or multiply polynomials, or binomials in this case, and as well as knowing how to distribute. So, and that is using the theorem segments of a chord. And so knowing that you have to multiply 2 sections of a chord that will equal the product of the other 2 sections of another chord. And so let's go on to our next page. So our next page talks about some core concepts that we discussed earlier and we wrote definitions for. We have a tangent segment and secant segment. So we have the tangent segment. Secant is tangent to the circle at an endpoint. The secant segment is a segment that contains a chord of a circle and is exactly one endpoint outside the circle. And then we have the external secant, which is the part of the secant that's outside the circle. Okay, so we have our external secant, which is just this part here. And then we have our secant segment, which is the entire segment. So in this case, PR, secant segment. And then we have our tangent segment, which is PS. Note, secant segments intersect at 2 points. Tangents only intersect at 1. And normally on the edge of your circle. So that is some core concepts. We're going to move on to our next 2 theorems. Our first one is the segment of a secant theorem. So if 2 segments share the same endpoint outside the circle, so if they share the same endpoint outside the circle, then the product of the lengths of one secant and its external secant equals the product of the lengths of the other and its external secant and its external segment. So, in other words, if I'm given EA, so I have EA here, and then I have to multiply it with EB, so that's everything, and then I have to set this equal to the product of EC, which is the shorter external secant, multiplied by all of ED. Okay, so in this example, we're trying to find X. So in order to find X, I have to set this up accordingly. So I have the external secant RP and RS. So I know if I take RP and I multiply it with RQ, then it should equal the other side of that external secant, which is RS, times all of the secant segment, which is RT. So now we can plug in our equation. So RP is 9. So 9, and you can use parentheses to indicate that you're multiplying. And then all of RQ, so RQ is all of this, so I have to add 9 and 11. So 9 plus 11 is going to equal RS, which is 10. And then all of RT, and RT is x plus 10. RT is x plus 10. So note, if they don't have like terms, you are adding in order to get parts of the whole. So 9 plus 11 times 9 gives me 180. And on the other side, I'm going to distribute. So I have 10x plus 100. And I'm going to subtract 100 from both sides. And I'm left with 80 equal to 10x. And I know if I divide by 10 on both sides, x will be 8. Okay, so that is for segments of a secant theorem. And so that's how you would find x applying this theorem. So on to our next one, we have segments of secants and tangents. So the first one was about tangents, the next one was about secant segments, and now we have secants and tangents segments. So in our next one, we have if the segment, we have two things, the secant segment and the tangent segment, they share an endpoint, and they're outside the circle. The product of the secant segment and its external equals the square of the length. So the square is here. So in this case, we have EA, so that's your tangent segment. And then we have our secant segment. Our secant segment is ED, and with our external secant, so we have to do ED or EC times all of ED. And remember, that part is squared. So for our example, we have A, B, C, and D. So we know that AB is our tangent segment, and then BD is our secant segment. So if we're going to find x, we know that x is, or AB squared, would equal the product of BC times BD. So we don't know what AB squared is, so that's why it's x. So x squared equal to 12, which is BC, and then BD is 12 plus 15. So x squared, and then 12 plus 15 gives me 27. So 12 times 27 gives me 324. And then we have to make sure we square both sides. So square both sides. And so our new thing with squaring is you always, when you square something, you will always have a positive and negative. You always want to choose the positive number in this case scenario. And the square root of 324 is 18. So that is an example for Theorem 10.20, segments of secants and tangents theorem. Our next page is onto extra practices. So in exercises 1 through 4, we need to find the value of x. And so in this case, both of our chords are on the inside, so we're definitely going to use the chords theorem for this. So I know that I have chord x, and I can multiply it with chord x plus 1. So that goes on one side. So I have x times x plus 1, and then I know it has to equal my other side, which is and my other side is 5 times 6. So now I can distribute. I now have x squared plus x equal to 30. And so in order to find x, I need to move my 30 over to set my equation equal to 0. This is also a review for algebra, so if you are struggling remembering this, please feel free to find me after school. So moving our 30 over, I have x squared plus x minus 30 equal to 0. And this is where I need to factor. And so I know I have to have two numbers that multiply to give me negative 30, but also give me 1. So if you haven't learned by now, you can always use diamond method. So on the top is your product, you want negative 30, and on the bottom you want your sum, which is just 1. Remember, negative 30 is your magic number. So what two numbers or factors of 30 can give me 1? Well, I have 15 and 2, but I also have 6 and 5. And the difference of 6 and 5, or the sum of 6 and 5, can always give me a 1. So I'm going to have a 5 and a 6, or a 6 and 5. But I know that I need to have a negative product, but a positive summation. So I need to make sure that I have my 5 is negative, because 6 times negative 5 gives me negative 30, but 6 minus 5 gives me 1. And so I'm left with x plus 6, and then x minus 5. And so I need to set both of my equations equal to 0 in order to solve what x is. Your shortcut is always reading what's opposite in parentheses. So I have x plus 6 equal to 0, so x gives negative 6. And then I have x minus 5 is equal to 0, and so x equals 5. And remember how I noted you can't have negative numbers in this case scenario, so you're going to choose the positive of x being 5. So that is number 1. So we're going to do a similar problem with number 2. We're still using the same logic. So if I took one chord and multiply it with the other part of my chord, so I have 10 times 7x, and it's going to equal the product of my other chord, so 15 times 5x minus 2. And again, you can use a dot for multiplication, you can use an x for multiplication, or you can use parentheses. So now I'm going to multiply 10 times 7x, and I get 70x. And now I'm going to distribute my 15. So 15 times 5x is 75x minus 30. I'm going to subtract 75x from both sides. So I'm left with a negative 5x equal to negative 30. And if I divide by negative 5, then I have x equaling a positive 6. So that is number 2. Now number 3 is different. So number 3, we are applying the secant segment theorem. So we're applying secant segment theorem for number 3. And that's why there's a little 1 down here. So we know that we can take our small, so we can take 2 and we multiply it by all of our chord or our secant segment. So that would be x plus 3 plus 2. Because I have to include that 2, I'm looking for all of it. And I'll do the same thing to the other side. So I have x plus 2, which is our external segment. And then we're going to take all of our chord, so multiplying that with x plus 2 plus 1. And so now I have to combine like terms if necessary. So I have 2 times x plus 5 on one side, and on the other I have x plus 2 And then x plus 2 plus 1 simplifies to x plus 3. So again, you'll have to use area model or FOIL in this case. I'm going to distribute my 2x. So I have 2x plus 10. And on the other side, you may use area model or FOIL. I'm going to continue using my area model. So I have x and 2 and x and 3. So x times x is x squared. Then I have 2 times x, which is 2x. 3 times x is 3x. And 3 times 2 is 6. So on the other side, I have x squared plus 2x plus 3x plus 6. So simplifying, I now have x squared plus 5x plus 6, all on one side. Okay, so now I'm going to subtract like terms. So I can subtract 2x from both sides. So I have 10 equal to x squared plus 3x plus 6. And then I can subtract 10 from both sides. And because I'm running out of room, I'll write it over here towards the bottom. I now have 0 equal to x squared plus 3x minus 4. And now I have to factor. So you can use diamond method here. So my magic number is a -4, and my sum is 3. Well, I'm only left with 1 and 4. That could possibly give me 3. So my first is x, and so then I need to make sure that I have a -4, but I need a +3, so that makes 1 turn into a negative, because -1 times 4 is -4, but -1 plus 4 gives me a +3. So I have -1 plus 4. And I set these equal to 0, or I can use the shortcut. So in this case, x minus 1 turns to x equals a +1. And then I have x equals a -4. However, I can't have a negative. So x equaling 1 is my solution. Now we're down to our last example, and this one is for the secant segment and tangent segment. So this one's both. So in this case, remember I have to take my tangent segment and it's squared. So I have x plus 1 squared, and it equals my other side, so my external secant, which is x minus 1. And then it's with the entire secant segment, which would be x minus 1 plus 5. So now I can simplify. If I have something squared, it's the same thing as saying it twice. So I have x plus 1 times x plus 1 equal to x minus 1. Then x minus 1 plus 5 turns into an x plus 4. So now I can use FOIL or area model for both. And so if I'm using FOIL, I multiply the first. So the first means the first term. So first is x squared, x times x. O stands for the outside. So x times 1 is just x. Then I multiply the inside, that's what the I is for, which gives me x. And then our last term, which is 1 times 1, which gives me 1. I'll do the same thing for the other side. So I have x times x, which is x squared. The outside gives me a positive 4x. The inside, -1 times x, is just a negative x. And -1 times 4 gives me a -4. Now I can multiply like terms. So I have x squared plus 2x plus 1 equals x squared plus 3x minus 4. So now my x squareds are going to cancel. And I'm left with 2x plus 1 equal to 3x plus 4. I'm going to subtract 2x from both sides. So I'm left with 1 equaling x minus 4 apologize, this is supposed to be a negative. So x minus 4, and I'm going to add 4 to both sides. So I'm left with x equaling 5. So that is my final solution for number 4. Your next page for 10.6 is a puzzle. Please feel free to find me if you are in need of any assistance. I'm here at 6:50 every morning, as well as after schools on on Wednesday and Thursday after school from 3 to 4. Thank you so much for watching my video, and y'all have a great day.